Crumpled paper.
So we are starting
Actually?
section 5.1.
Actually,
And what's this topic?
No, this was, we're talking about the workbook, like the paper folding.
What's the topic?
Exponential growth.
Exponential
I did TS
Exponential growth.
functions and their graphs. So this is a little definition for you. The exponential function f with base a is denoted is written, f of x equals a to the x, where a is greater than 0. A is not 1. Why can't a be 1?
Because then no matter how much you multiply it, it's still equal to 1.
Right. And x is what?
An element of all reals.
So x is a real number. Yep.
Does that say at value next to
Yeah. So we're going to evaluate.
As an exponent after the 2, correct?
So that's x as an exponent over a number. Yep, that's the exponent. So evaluate at x equals 3.1. This is it. So this is a. So this is negative 3.1. And this is probably something that you'll do with your calculator. So x 2 to the minus x at x equals pi. So I want you to do all of these.
Is this logarithms stuff?
So this is not logarithms. This is what?
Exponential.
Well, I know, but I wasn't sure if they were kind of like synonyms.
Oh. In a way. Do you know what way?
Oh.
Do you know what way?
Absolutely not, but I had a sneaking suspicion.
So would you say addition and subtraction are synonyms?
They're reciprocal.
Or what's the other math term?
Inverse? Or
Inverse functions.
Okay.
Are multiplication and division synonyms? No.
They're reciprocals.
Inverse.
They're inverse functions.
Oh my God.
Are logarithms and exponents synonyms?
No.
No.
What are they?
They're inverse.
What does that mean?
Reciprocal.
Yeah, what does it mean?
Different.
They
Absolutely
cancel each
opposite.
other out.
Yeah.
They cancel each other out.
Like they're not opposite, but
I
like
don't know.
opposite.
So the exponential function of a log would then equal the base, right?
So if I say
What's log?
so if I say 2 to the log base 2 of 7.3, Patrick, what would you predict that is going to end up being?
2. What would be 2 to 7.3?
No, this 2 to the something and log base 2 are reciprocal functions. So this is kind of like saying 3
2
times
to
7.3 divided by 3.
So it's 2
Okay, so
to
it'd
the
be 7.3. Got it.
And then what was this one?
7.3.
Right. And or if I said log base 3 of 3 to the 4.9?
It'd be 4.9.
4.9. Why?
Because they cancel each other out.
Because log base 3 and 3 to the exponent are inverse functions. This is a preview. I don't expect you to actually understand this or know this. It's just kind of the concept of this cancels. What is 7.3 plus 4 minus 4?
7.3.
Why?
Because 4 minus 4 cancels out 0.
Well, the way I'm thinking about it is plus and minus are
Reciprocals are inverse functions.
inverse functions, right? Yeah. Little preview. Okay, let's keep doing like this practical stuff first. X equals 3 over 2. All right, can you take out your calculator and give me an answer? So I'm gonna write this as, and I want you to write it down and I'm gonna come around.
Wait,
So you're gonna write the answer as f of minus 3.1. Here you're gonna write f of pi, and you're gonna write f of 3.2, and you're gonna give me an answer. All right, so let's look at a couple of graphs. We're gonna do this by hand for a minute.
What?
So if I do x, and then I do 2 to the x, and I do 4 to the x, so I'm just gonna start filling in values, and then you fill in the rest of the table, okay? So minus 2, minus 1, 0, 1, 2, and then 3. And then we're gonna sketch this as well. So you're gonna fill in this table, and you're going to graph these points.
Okay.
So here's x. X is minus 3. Where's x is minus 3?
No calculator, right?
No calculator. Do this with your meat computer.
Okay,
On our final, our final will have Desmos test mode and calculator allowed, correct?
I reserve the right to give you your final in 2 parts. So if I give it to you in 2 parts, I'll give you the no calculator part first.
Okay.
Then you hand me your no calculator part. I give you the other part with your
Is that what
calculator.
you're thinking now?
No, but that's like if there's stuff that I don't want you to have access to. Like there might be a part that's no Desmos test mode because I don't know how to get log base conversions restricted in Desmos test mode, but I know how to banish it from TI-84.
So you're gonna banish it from RTI-84.
So for this class, you're not going to use log base. So log base is a convenience of the calculator to let you. This is preview. We're not even there yet, but eventually you're going to be able to convert something from one base to another. But you're just going to do it algebraically, super easy. But your calculator can do it too. But I don't want for this class. I don't want you to use the calculator.
Not the calculator to do the other stuff, but a calculator to do the basic algebra.
Don't know. That was the other question I was answering. Is I might
Okay.
give you a part of,
Well, for
of the
that question
test.
where it's we can't use the calculator for the
At
log
all.
case, but we could use it
Oh, sorry.
for that problem, but we could use a calculator to do the plugging in numbers part.
Yeah.
you
So
get what I'm
so if I can't figure out how to banish log base from Desmos test mode, I probably will give you any log base questions on a no calculator part.
Okay.
So you'll just do those with pencil and paper, and then you'll hand me that part. I'll give you your rest of your test with your calculator.
What would X be? So if we got Y is 64, what would X be? Would X be 4?
So this is your x value. So here at minus 1, 2, 3.
Oh,
That's where I'm gonna graph my result for these 2 lines. And then I didn't need all this extra space over here. So I want to see what your charts look like. So can somebody give me the line for 2 to the x? Matt, can you get me started?
For 2 to the x?
Yeah.
Okay, 0.125.
No, I want fractions.
Oh,
I want fractions. You're not using your calculator for this.
1/16.
Can you start here? Can you start with 0?
Oh, 1,
Mm-hmm.
4,
Where?
wait, 2, 4, 8.
Uh-huh.
Sorry.
2 to the 2 is 4. And then 2 to the 3 is 8. And then can you give me the negatives too?
Yeah, so -3 is 1/8,
Right.
and then -2 is 1/4,
Right.
and then
Whoops.
-1 is 1/2.
Mm-hmm. Positive 1/4. And then 1/2. So where is 3 1/8? And where's 3 comma 1/8?
It'll be -3, so that way.
Yeah.
And then up,
Up just 1/8?
yes.
Okay, and then Baron, where's minus 2 1/4?
Minus 2 1/4. That's like 2x, right? Oh, you're saying for 4. Minus 2 is 1/16.
No.
4 to the -2 is 1/16. Right?
Do you see what I'm working on right now? I'm working on just this line. It's not 4 to the anything. We're not even doing that. It's 2 to the -2. 2 to the -2 looks like this. 2 to the -2.
And then you put it into the denominator.
Put in the denominator,
You get 2/2 is 1/4. But
and that's 1/4. So where is 2 comma 1/4 as a point?
-2.
Oh, -2.
Then that would be over -2 1/4.
So up here,
Yeah.
and then Patrick, where's minus 1 1/2?
Minus 1 1/2. So it's halfway above.
And then Matt, where is 0, 1?
Up 1.
Up 1 on the y-axis.
It is.
And then 1 2,
Oh my
2
goodness.
4, 3 8, and it looks like this.
Whoa.
Okay.
What?
And then what does 4 to the x look like? It's even shallower over here.
I can do it real fast.
Crosses 0 1.
Wait,
But-
what you're telling me is it's an
It's
That's
even
what-
shallower
What?
over here and crosses and then goes even steeper.
And the more you, the larger the base, the more like blocked
Oh,
off
we
it is,
have
right?
prefect.
And it's more blocked off. So if it was 100 to the 4th, it would look like this. Thanks, guys.
I have a prefect.
Me too.
Discuss that before.
Oh yeah, you are.
See you there. I am the prefect meeting.
Yeah. Well, yeah, but we get pizza.